Hi, Professor. This is Daniel Riseman with assignment 1.4. For question 12, given that a and b are any non-zero real numbers, describe the graph of ax is equal to b. Well, I picked some numbers here for one space. I said a is 7 and b is 2, and in doing so, I get a result of x is equal to 2 7s. In one space, that would just be a point. In two space, I picked some points. I did a is 10 and b is 4. I get a result of x is equal to 2 5ths. In two space, that would be a vertical line with a slope that is undefined. In three space, I again picked some values. A is -2 and b is 6. I got x is -3. In three space, that would be a plane, which is quite interesting. Moving on to question number 17. Well, question number 17, determine the y-intercept in terms of a, b, and c for this equation. Well, you isolate y by itself because you know that y is equal to mx plus b. And in doing so, we get this is our slope, -a, b, x, and this would be cb, and that is the y-intercept. So when the x is 0, the y is going to be c over b, and that would be the y-intercept. And I picked some points and gave some examples and graphed it as well, and I sent it to you. For question 25, graph the absolute value of x plus the absolute value of y is equal to 1. Well, I did that here in two space, forming a square. I initially thought it was a rhombus, but those are negative reciprocals, same there and same there. So it's going to be 4 right angles, and all the sides are equal, so that is a square. But you'll see there's a big difference between number 25 and what happens with when we compare that with 24. That's what question 26 is about. Now, doing question 26, I graphed all 4 equations with number 24. You can see here's 1, here's 2, here's a third, and here's a fourth. These are going to form that inner square, but these are lines. They're going to have infinite numbers on here, right? And same here. They're going to go on for infinitely. And that's a major difference. Their domain and ranges are going to be very, very different than what we had for problem number 25. And here's the detail of that. While problem 24 contains the inner square that is formed in the graph of problem 25, it is important to note that the 4 linear equations of problem 24 are lines that extend infinitely, as detailed by the arrows at each end of the lines. As a result, those 4 equations have domains and ranges that extend for all real numbers, while problem 25 has a very restricted domain and a range. Specifically, the domain for problem 25 is x is greater than or equal to -1 and less than 1, and the range is going to be y is greater than -1, greater than or equal to -1, and less than or equal to 1. For number 27, it's important to note that we want to see what happens when b is 0. And when b is 0, you're going to get things that are undefined. 0 in the denominator means it's undefined. If it's undefined, it's not going to exist. So what happens when b is 0, you get undefined and you don't have a slope or a y-intercept. For part B, explain the reasons in why moving vertically -a over b units for every 1 unit movement horizontally is equivalent to vertically -a units for every b unit horizontally. Well, the reason that works is because in this situation, if I say y is equal to -ab over 1, that is the same as saying this. And since the slope is change in y over change in x, what you can do in this situation, the change in y would be this, and the change in x would be that. There's our slope, and I detailed all the movement here. Moving down, in this situation, down 3/4, over 1, down 3/4, over 1, and I gave everything detailed right here. And that's the same as saying with the movement of -a over b, and you're going to move it, again, you're going to move it down 3, and then over 4, and you get the same graph that we had for the previous one. And that was an interesting one to think about, and I detailed it very well here for you. Thank you, Professor. I enjoyed this, and I will speak with you soon.